Welcome to Math Minders Academy. Today we are going to look at curve sketching, and we'll be giving attention to quadratic functions. So we are going to learn how to sketch quadratic functions. If you are new to our channel, click the notification bell so that when we release a new video, you'll be among the first to receive it. Subscribe to our channel so become one of our community members. Let's proceed to curve sketching. Now, if we are given a quadratic function, let's take an example. If we are given f of s equals x squared minus 5x plus 6, how do we sketch this curve? The first thing we do is to determine the root of this equation. We turn it to equation and determine the root. So we determine the root by setting s squared minus 5s plus 6 to 0. We say s squared minus 5x plus 6 equals 0. Factorizing, we have, of course, we know that if we multiply 2 and 3, we'll get 6. If we multiply 2 and 3, we'll get 6. We are looking for the sum of these factors that will give us minus 5. So we are going to have negative, negative, so that minus 2 times minus 3 will give us plus 6, which we have as our constant value here. And minus 2 plus minus 3 will give us minus 5, which is the coefficient of s. And so with that, we are going to rewrite this quadratic equation. So that will give us x squared. We use minus 2x minus 3x plus 6 equals 0. So we can have x into x minus 2 minus 3 bracket x minus 2 equals 0. So we have x minus 2, x minus 3 equals 0. Solving, we say either x minus 2 equals 0 or x minus 3 equals 0. Therefore, s equals 2 or s equals 3. Now, after that, we are going to determine the y-intercept. That is number 2 step. We are going to find out what is the y-intercept. So we go on to find y-intercept. And this happens when s is 0. So we are going to look for f of 0. That gives us 6. Now, the next step, which is step 3, we are going to look for the turning points. Look for the turning point. So here, the value of s at turning point is determined by minus b all over 2a. Full explanation of how I got minus b over 2a is in this video here. So click on that video. You are going to get a full explanation of how to re-express quadratic function into a vectors form. So here, you remember that our A here represents the coefficient of S squared, which is 1. B is the coefficient of S, which is -5. And C is the constant, which is 6. So this is going to give us -5 all over 2 times 1. And that gives us 5 all over 2. That's 2.5. All right. Now, with these 3 steps, we can go on to sketch the curve. So we go to the graph, and then we mark off the roots of this equation where S is 2. This is where S is 2. This is where S is 3. The curve is going to pass through there. And then if we look at the nature of this curve, the coefficient of S squared is positive. So the curve behavior is going to have a pattern. It's a parabola in the shape of letter U. So we know that's how the curve is going to go. And now the curve is going to cut S as the y-axis at the point where the value of y is 6. Then we look at the turning point where S is 2.5. We are going to get the y value of this turning point. That is, the turning point S is 2.5, then y is f of S, which is f of 2.5. So when we put in 2.5 into the original equation to get the value of y at turning point, it gives us -0.25, which is a point somewhere around here. Around here. All right, so let's now sketch the curve. So putting all these pieces together, the curve will come, we cut here, come down, cut this place, turn, and then move. All right, this is curve sketching. So we've been able to sketch this curve. And now compare it with the original function that is sketched using table of values. So look at these two. You will see that both of them look very much alike. So we are going to proceed to the next example where our parabola will take another shape. We're going to consider another kind of curve that will have an N shape. Let's proceed to the second example. Supposing we are given the function f of s equals 5 plus 4x minus x squared. So as usual, we are going to find the root. We're going to find the root by setting this function to 0. So we obtain the equation 5 plus 4x minus x squared equals 0. Now, if you multiply through, if you rearrange this, move everything so that you properly see this equation, you're going to get x squared if you multiply by -1 minus 4x minus 5 equals 0. All right. Now, finding solution to this equation, we look for factors of -5 whose sum will give us -4. So if we use 1 and -5, you remember that 1 times -5 is -5, and 1 plus -5 is -4. So we'll rewrite this as s squared So we're going to have plus x minus 5x minus 5 equals 0. We have x into x plus 1 minus 5 into x plus 1 equals 0. We have x plus 1, x minus 5 equals 0. Here you have x plus 1 equals 0, or x minus 5 equals 0. So s is minus 1 or s is 5. Now we've been able to get the roots. Then the next step is for us to get the intercept. So we are going to get the intercept on y-axis. The intercept is the constant there, which if you consider this original equation, the constant term is, if you look at that, that is 5. That's the y-intercept when s is 0. So if you want to get the y-intercept, you are going to get it doing f of 0, and that gives you 5. Now, the next, we are going to, the third step, we are going to get the turning point. So for this turning point, we are going to look at the value of s and the value of y. So we have x equals minus b all over 2a, which is minus, you can use any of the equation, but if you, whether the original or the adjusted one, it works. So b here is 4 from the original equation. B is 4, so we have minus 4 all over. A is the quotient of s squared, which is negative, which is minus 1. And that gives us 4 all over 2. We have 2. So the y is, the y value of this at turning point, the y is going to be f of 2. And if you look at f of 2 here, that is 5 plus 4 times 2 minus 2 squared. And that is going to give us 5 plus 8 minus 4, and that gives us 9. So the turning point is, of course, when s is 2 and y is 9. Okay, so with this, we are going to use this 3 information about the curve to sketch it. And remember that the value of s squared is negative. So since the value of s squared is negative, the curve is going to have a pattern that looks like letter N. So let's mark off the roots. The root is when s is minus 1, it will cut at this point. And when s is 5, it's going to cut at this point. Then if you look at the intercept, it happens when y is 5 and s is 0. So it's going to be between 4 and 6 around here. It's going to cut. And then the turning point is when s is 2 and y is 9. So we're going to have it up above here. So if we join all this together, we'll be able to sketch the curve. So we're going to have a curve that will move this way. We come, slowly hit this, get to this place, turn, and then we have this. All right. So compare this with the computer graphed example of this function. You will see that they have huge similarity. And so Go through this tutorial video once again and see how you can apply this principle to sketch as many quadratic curve function as possible. If you are new to our channel, click the subscriber button so that you become one of our community member, and hit the notification bell so that when next we release a new video, you'll be among the first to receive it. Go to the comment section and tell us how you feel about this video. Be with us next time when we'll be discussing another interesting topic in mathematics. This is Maths Minders Academy. Goodbye for now.
In the midnight glow where the stars align, we lose ourselves in the rhythm divine. Underneath the sky painted with dreams, we're chasing the echoes of silent screams.